Hello. So today we are going to solve this permutation problem. This is a classic problem, and as you are aware that in this problem we are given an array of distinct integers, so no two integers are the same, and the requirement is that after processing that input array of distinct integers, we have to return all the possible permutations. So as an example, if we are given this input array 1, 2, 3, then we need to return a list of all the different permutations of these three elements. So as we know that distinct permutation of three elements is 3 factorial, and that is 6. So this list is having in total 6 elements, 6 sublists, and that's what we need to return here. So for in this case, if there are only 2 distinct elements, then 2 factorial is 2, and this list contains 2 elements. And if there is only one, then that list is the list of only that element. Pretty obvious. So now the first thing that is obvious that we need to return a list of integers. So let's first declare a list of integers. Let's name it as result is equal to new array list. Okay, this is done. So this list will contain the result that we are going to return. So we need to return this thing. Okay, so and now the second step, we are going to create permutations of all the elements in the nums array. So in order to create that permutation, we need to store the elements in that nums array in another list, and that list, after creating the permutation, will be added to the result list. So I'm talking about these lists, these sublists. So these sublists need to be generated by our code. So we need to create one list here. Pretty obvious. So this list will be called as partial solution. Okay, we can name it as partial solution. That is very clarifying. Okay, and we are going to use this partial solution to build our solution one component at a time. One component at a time, what does it mean? When I'm saying one component at a time, it means that in every call we are going to select one particular element. So sometimes we may select one, in other call we may select two, and in some other call we may select three. So that's how you build the permutation. So you need to have that mechanism of selecting elements arbitrarily. Okay, and in order to help us to select the elements arbitrarily, we need to have a check whether that element is used or not. Okay, so we are going to create one array here. We could have used that since a list partial solution, whether it contains that element or not, but contains will be invoking that equals method, and it is pretty time consuming. It's better to use used array. It brings out the same effect in much less time. Time complexity will be less if we use this used array. Okay, because then the lookup is just array has got O of 1 lookup time, as in the case of map, but it is much more simpler than going for the map. It will be clear. Now we are going to call another helper function. Okay, and in that we are going to pass this nums, this partial solution, this used, and could have used this result as a global variable, but somehow I not very like I don't like using this global variables. I rather prefer going with the local variables. That's my way of doing the things. So I'll stick to my preferred way of doing things because yeah. So now we are going to create the same method. We are going to overload the method, and that method will be having different list of parameters than the existing one, but it will take that nums array. So we are going to pass this nums array. Then we are going to pass this partial solution. So we are going to pass this partial solution. Then we are going to pass this used array. So we need to pass this, we need to declare this in the argument list. And finally, we need to declare this result list of list, because this is the final list that we are going to return. And this will contain the partial solutions. Now, let's go ahead. Now, we need to go through all the elements in the nums array and check whether that element is already chosen or not. If it is chosen, if used of I is true, then we don't want to do anything with that. And that's why we am returning continue. So it will go to the next iteration of the loop, for loop here. If it is not used, then what we are going to do, we are going to add that to the partial solution. Okay, we are going to add that to the partial solution and make that used location, the used, for every element in the nums array, there is one corresponding same index in the used array, and that used array index is telling us whether that element in the nums array is used for building the partial solution. We are building the partial solution component wise. So we are going to put one through here, and in this we are going to use permute, and the permute we are going to add nums, and after partial solution we are going to pass the partial solution. Then we have changed the used array, so we need to pass that as well, and finally we need to pass that result. So this permute call is basically, we have made our choice in these two lines. We are done with the choice, and then we are asking the next call to explore further. And recursion is a very good mechanism to do exploratory calls. Whenever in algorithms we need to explore something, we use recursion. So this recursion is doing the exploration on the state space search tree, and state is this partial solution, and recursion is exploring that state space search tree, and we are starting from the root and going to the leaf. If the leaf node is satisfying the criteria, then that is the goal node, that is the answer node, that is the solution answer node. To be precise, it is the answer node. Okay, all leaf nodes could be solution, but one particular thing which satisfies the constraints, then that is the answer node. So I would comment the line here that we are doing the exploration here, exploratory call to further depths of the state space tree. And here in these two lines, we are in this and the line below, we are changing state. Okay. And now, so after exploratory call, when we come back to the same node or states, what we want is that since we are done with that exploration, we want to remove back that element from the partial solution because that exploration is accomplished. So to remove that thing, what we do here, partial solution dot size -1, and again we set it back, that used array to false. Yes. So this will be the part of a for loop, but we have not yet defined the base case of this recursion. To define the base case of this recursion, we need to put a check. When the partial solution dot size, the size of the partial solution is equal to nums dot length. If it is equal, then we have, we are at the leaf node. We are at the leaf of the state space tree because there's nothing, no more elements to be chosen from nums array, as everything has been chosen, and the used array for all the indexes of the nums array would be having true value. So there's nothing to be chosen and everything has been put into its place in the partial solution. So what we need to do, that we need to add this partial solution to the result list of list. So result is going to contain the partial solution. So you may ask, like, why we are doing this new array list to the partial solution. Basically, we are cloning this partial solution. We are cloning this partial solution so that we are doing a copy of this partial solution, and this copy is being stored because this is a typical backtracking thing, and we are going to add elements to the partial solution. We are going to remove elements to the partial solution. So at some stage of time later down, this partial solution may become empty. At the end of it, it will become empty. And we don't want that empty thing to be here. We want the snapshot of the current state of the partial solution. And as you know, in Java, when we are storing this partial solution in the result list, then a reference to the object is being stored, not the actual object. So later down, that reference to the object, that referred object, may contain different values than what we have right now at the point when we are writing this line. To save us from that kind of situation, we are cloning that partial solution with a new array list, and that new array list is now containing the same elements which the partial solution is having right now, and then that is being saved so that we are immune. Now we are, immuning ourselves from letting the sublist elements to be, changing further down. So that's why we are cloning this partial solution. This partial solution has different values at different stages of the call. So that's why we are doing it. And we are not going to remove this anything from this. We are we are going to put this inside an else block. Maybe we need to do some formatting here. This should be further indented. I'm using tab. Some people may not like it, but I don't think there is in this editor we can do anything else. So now it seems okay. Now we need to return the result. So there is no better place than this to return the result. Okay. So at the end, we are going to return this list, and this should mark an end to our solution. So let's run it and see how it behaves. Oh, it's accepting. Very good. It's giving the result for all the cases. Let's do some further cases. We'll add some fewer more elements. Let it be 2 only. This is 4, this is 2, and then this is 0. My favorite number. What is the result? Perfect. Perfect. So let's submit it. So this solution beats 81.41, and it's as good as some of the best solution, not the very best, but it is good. We are using collection classes. That's why it's not that good. Had we used map here instead of this use Boolean array, it would have, the performance would have degraded even further, but we are using this for that reason precisely. We are using this used array, and that's why this is doing a good job. The solution is doing a good job. It could have been better, but it would unnecessarily add some more complexity. So for now, thanks a lot.